All right, so one way to summarize data was calculating, for example, mean, median, or other criteria like standard deviation and so on. But there are also other methods like using plots, which is very useful because visually, when you take a look at for example, these plots, then you get idea what's going on in your data and your data distribution. So let's go through them. And I also in this slide showed you which chart can be useful for each type of data. For example, I said pie chart is good for nominal data because it shows the ratio among the data that you have for that attribute very nicely. So for bar chart, it's usually good for showing the frequency of the data. And for histogram, for illustrating frequency of interval and ratio data. Again, two different types as you can see here. And stem and leaf, we can use it for interval data. And they are not like to say, for example, always this is the case. You can even use, for example, a stem and leaf for ratio data. But usually these are the cases. And right away when I receive, for example, an attribute which is nominal, I'm thinking, let's check what's going on in terms of pie chart to see what's going on there as the attribute. Because when I say attribute, like attribute 1, then under it you will have several data. Let's say the number of data is so big, like 3,000. Then one by one, I don't want to go through them to, for example, get idea how many, for example, male I have, how many females I have. So by just constructing the pie chart, you get idea what percentage are male, what percentage are female easily. And that's the place we need softwares so that we can draw them. So from now on, it's not a bad idea. You guys go through Excel or SPSS or R programming to practice with it. This is out of the scope of this course, so for me to teach you guys about those softwares. But anyway, Excel is very easy to work with. I'm sure all of you guys are comfortable with it. But if you are also interested, use SPSS and R programming. Then if you have any questions about them, of course, we can talk about it. So one by one, let's go through them. But before that, also let me introduce you to a scatter diagram, which is very good to show the relation between two data, and box plot, which we will talk in details in tutorial, and time plot, like time series, which is usually related to the trend based on time. So as an example for pie chart, you can see here that for each segment, we've shown them with the color, and based on the percentage, you can decide what's the angle in for this segment. Like if you want to find, for example, alpha, let's say this is alpha angle, then how can you find it, by the way? When you use software, it doesn't matter. You don't need to provide us what's alpha, what's beta, and so on, but just draw the pie chart. But let's say you want to know what is alpha here. So if it corresponds to 40%, what's alpha? If I know the whole angles that I can have here, what's the degree of that? What's the degree of the whole circle? This is 360 degrees, right? So by using this proportion easily, you can find alpha, okay? So that's the way you can find it and draw it. But when you use software, and specifically Excel also provides it easily, then you can just provide it using that. So you just select that attribute, and based on that, you can provide us the pie chart. This is very useful because right away, by take a look at this, you understand red segment has more proportion, right? And yellow segment has the smallest portion. But assume that these attribute has 3,000 number of data. It was not easy to see that, but when you look at this, easily you can understand that this is the case. So summarizing data can be very useful, as you can see. What about bar chart? As I said, it usually corresponds to frequency. Also here in this example, you see relative frequency from 0% to 100%. It is also possible to use for relative frequency as well. So by comparing them, you understand that this one has the highest value and these two have the lowest. Histogram, as we mentioned, this is very useful for interval and ratio data types. And it's very good to show the trend and distribution. You understand, for example, here, many of the data is concentrated on this part, but can I say this is symmetric or not? Not exactly, you see. So based on some measurements, you can even decide whether I can consider symmetric or not, because it could be a sample for a population which is normally distributed, right? So maybe that's the case, and because the size of sample was not big enough, that's why you couldn't have better histogram, right? So these trends will give us some ideas as well. Another way to summarize your data is using stem and leaf. And here you can see in this diagram that we have summarized the data. But what does it mean? Like here we have 9, 15, 19, 22 until 139. Okay, so as you can see, when you want to choose your stem and leaves, here this is the stem part, and you can see the leaves part on the right side. So on the right side, only one digit should be considered. You see the first digit. So 0, 9. You see? So here we have 5. So on the left side, we have 1. Here, first digit only should be on the right side. So you will have 2 digits on the left side. So you see here we have 2 digits, here we have 1, but always the leaves are corresponding to 1 digit. So if I want to show 9, I show 0, 9. It is also possible to show 0, 0, 9 because you have 2 digits here. It is also possible if someone prefers that, but it's also correct like this. So you see, when you do that, then based on what digits you have on the left side, then you can organize your data. So from 1, even from 0, 0 to 9, all of them will be inside this row, right? So by looking at this diagram, I understand only I have one value, which is 9 inside this interval. By looking at the second row, I understand that 15 and 19 are the values that it has. So between 10 to 19, I have 2 values. So you see, it's somehow similar to histogram because we are here considering interval by interval. Here also the same way, but we show also the values, which is the beauty of a stem and leaf. So this is useful also to find modes, medians, and in this diagram can give us some ideas. Like for example, here you see the majority of data happens inside this interval, right? So a stem and leaf can be very useful. And a scatter diagram as well, because it shows the relation between 2 variables. In the lecture related to regression, you will see this slide again. I will tell you how to even calculate a model for it. But now let me show you on this slide, and I will tell you in detail what they mean, each one of these diagrams. So all of them are called scatter diagrams. It shows, for example, for X and Y, all the possible data and point-wise, we are illustrating all the data here. So based on what we can see here, there is no relation between X and Y. It seems to be random. But here, maybe there is a relation, but this is a low correlation. And here you can see a high correlation. You see, compare these two together and you understand what I'm talking about. It means that X and Y somehow are related to each other, you see, and linearly they are related here. And if it happens to be exactly on the line, which almost never happens, always we have some differences between X and Y. If that's obvious, usually we don't check it in nature. So usually that's not the case that perfectly it happens. So we are dealing usually with these three cases. And also we should know about the type of them, not just the degrees of correlation. Like for example, here they are positively correlated. What does it mean? If I increase the value of X, the value of Y is expected to be increased as well here. But if you increase value of X and you observe that Y values are decreasing, then they are negatively correlated. And it's not always linear. You see, sometimes it could have a curly shape like this. And that's why when you want to model them, then linear regression, for example, won't be useful for a curved scatter diagram like this. So for these two, linear regression can work perfectly. And what about this one? Sometimes we can see they are partially related, and starting from a specific value of X, suddenly it seems to be random. So we say partial type of correlation was observed in this scatter diagram. So a scatter diagram can be very useful when you have two variables and you want to see the relation between these two variables. And box plot. We will practice with it in details in the tutorial, and this is very useful to show the distribution of your data. So as you can see, the terms median, third quartile, first quartile, we already talked about the minimum, maximum of your data. You can see on this box plot. So this box plot, the problem it has, it doesn't show the outliers. We can also draw a box plot which shows outliers, which we will practice in the tutorial, and it is very important to learn about them. So here we consider minimum and maximum as the tail of our box plot. And here in this box, you can see 50% are concentrated. And this distance, you remember, this is the interquartile range. So what you do when you want to construct a box plot? As I said, we will practice it in detail. So let me talk about it in details in the tutorial. But just to know, first you show median. Then you show two lines for third quartile, first quartile, because you should calculate them. And just connect these two together and you have your box. Then to find the tails here, then here it's easy because this is the maximum value of your data, here minimum. But sometimes you need to construct a box plot which shows outliers, and we don't consider minimum and maximum for these two parts. Okay, and I will show you in the tutorial in details. What about time plots, like time series? For time series, you can show the trend based on time, and each one of these data, you can see the values are corresponding to y-axis, and here you see the time. So based on time, you can receive different data. Let's say we are talking about weather temperature. So weather temperature in the last 40 days, for example, this is the case. The beauty of time series is that when you have information about your previous data based on time, then you may be able to predict what would be the weather temperature tomorrow. What would be the weather temperature, for example, 2 days later? And it is a very good method for forecasting. That's why when we talk about forecasting methods, time series is always one interesting one that we are using. If you are interested in this topic, you can also read my articles related to forecasting psychological systems using time series. If you are interested in that, just Google my name along with time series, and for sure you will find those two articles which are related to this. Okay, guys, I hope lecture 6 was useful for you, and I will explain about whisker and box plot in details in the next tutorial. See you guys.